Okay, let's start. First off, welcome to this talk about Elm, beyond JavaScript frameworks, and how you write reliable web apps with Elm. I'd like to start with a question. So who of you knows about Jonathan Ive? Who is Jonathan Ive? Okay, maybe a fifth of the audience. Jonathan Ive is the Chief Design Officer at Apple, and maybe the second most influential guy for all of their products after Steve Jobs. And the reason I would like to start this talk with talking about Jonathan Ive is that my colleague has this great quote about Elm that I really, really love. And the quote goes like this. Elm is like Jonathan Ive would have designed a programming language. It is minimalistic, it is user-friendly, and it just works. And of course, this is a bit on the extreme side of things, but still, I think it captures the essence of Elm in a way. And during the next hour or so, I will try to show you why I think this quote is so fitting. So I have a few more questions for you. You don't have to raise your hand, just think inside of you if this goes for you or not. So first off, how many of you write JavaScript for work? Actually, here I want some hands. That's pretty much everyone, so that's good. You're in the target audience for this talk. For the following 4 questions, just think for yourself. So maybe you ever shipped an app with confidence that it wouldn't crash in production. Like there's zero chance that it would ever crash in production. And if you did lots and lots of QA, that doesn't count. For one of my previous projects, we did like 3 weeks of code freeze with no changes to the code base, just doing system testing before we could make the release. And in 2018, you don't want to be working like that. And did you ever feel completely safe after a large refactor of the JavaScript code? Like really, really large, touching all of the core domain logic? I know I wouldn't. Did you ever become overwhelmed by the amount of front-end technology that you need to know in 2017 or now 2018? I mean, you have React, you have Redux, you have all of the other view parts of the layering cake, and then you have the build tools, Webpack, you have the add-ons like immutable JS and TypeScript, Flow, etc., etc. And because of all of these new tools, maybe you ever felt like not everyone on your team was comfortable with the front-end tasks. I know in my previous teams, there's always been this partitioning into like the backend people and the front-end people, and the very few people are actually comfortable on both sides. So for me, as working as a full-time, large-scale JavaScript consultant for the past 6 years, I can safely say that I felt all of these pains personally. I felt the JavaScript fatigue. There's even a word for that now. The worrisome refactorings where you really have to change the way your app works, but you really, really don't want to. And you have the dedicated front-end developers. I know I am one. I would like to do more backend stuff, but it's just so much things you need to know to be a professional JavaScript developer. And also the nail-biting deploys. I worked at a large bank some years back, and like those big deploys, I don't want that for anyone. So I will argue that Elm addresses all of the issues. And that's why I think that Elm is so interesting as a piece of technology. And while it also addresses these issues, I feel that it also provides a dedicated pair programmer because it's a compiled language. So you also have the compiler by your side all the time, being your dedicated pair programmer that's never sick, never hungover, never goes on vacation. It's just always there. And it also provides error messages that actually help. You know, John Carmack, the lead developer behind Quake, Doom, lots of the great games of the 90s, actually has this great tweet about Elm and its error messages. Because Elm is one of the I don't remember the exact wording, but Elm is has one of the best error messages in the world. And lastly, it has a solid package system. You won't be able to publish a package unless your public API is thoroughly documented, and that's enforced by the language itself. And it enforces semantic versioning and all these other good things. So before we delve deeper into Elm, I guess I need to present myself. My name is Erik Wendel. I live in Oslo, and I work as a consultant. I've been working mostly with JavaScript and mobile technology now for the past 6 years, focusing on the user interface part of things and really nailing that part. I worked with some large-scale Norwegian companies like the Norwegian Railways, NSB, and Sparebank 1, which is the second largest bank in Norway. At Beck Consulting in Oslo, I'm the web development lead, and I'm also the founder of Oslo Elm Meetup and Oslo Elm Day, a one-day conference about Elm in Oslo. At my current client, NSB, we are currently using Elm, and we're serving Elm in production to over 1 million users buying train tickets every day. So, this is today's agenda. First, we start off with a little deep dive into Elm, how it works, and how it compares to the JavaScript solutions of today. Secondly, I'm going to live code a very small app for you to show how the development experience is. And lastly, I'm going to share a little bit about my findings when I asked the question, does anyone actually use Elm? I mean, it could be a really great technology and all, but if it's not ready for production, if people aren't using it, is it really that interesting, right? So this is what we're going to look at today. So let's start with how Elm works. First off, you said that nearly all of you use JavaScript at work. So I guess you can all tell me what this is. What will this code produce? This is actually running JavaScript code. You could parse this into your console. It will produce an output. So this is actually a string. I'm guessing you all saw that immediately. And this is a string hello NDC. And while I guess many of you have seen that this is actually valid JavaScript, I would like to show you why and how it works as a small example of how wonky JavaScript can be before we delve into Elm. So I'm going to give myself a little challenge. I'd like to be able to produce the letter E, which is the first letter of my name, Erik, without using any more than these characters. So, arrays are a really fun thing in JavaScript. They're not actually arrays, they're objects, a special form of objects where all of the keys are numerical indices. So we can do a lot of funny things with arrays. We could try to use the unary addition operator, the plus operator with an array, and it will be coerced into a number. So that will be 0, plus array is 0. Okay. And we could try to, let's say, negate that. So what's not plus array? That's true, because the 0 is coerced into a Boolean value, which is false, and then it would negate that, which becomes true. So now we have an E, but the problem is it's not a string, it's a Boolean value. As always in JavaScript, when you want to produce a string, you would just plus it together with an array. Voila. There we have the true. So now we just need to get the number 3, and then we could access the third character in this string. So let's try to produce the number 1. Let's start with an array again. We could plus that. But now we have 0, so no amounts of 0 is going to get us a 3. But we could try to go the path we went with earlier and negate that. Sorry. That's an illegal character for this task. So if 0 is false, then maybe 1 is true. So let's try to plus the true. Aha. So if we would just do this enough times, we could basically create any number using only those characters. That means that if we revisit our earlier true string, and we would wrap that in some parents, and then try to access the, oops, like that, and then just do our little trick again. Voila. And the reason I'm doing this is to show you that JavaScript was made in 10 days, as I guess many of you know. And while it's a great language, I really enjoy working with JavaScript. Writing new code in JavaScript is just such a breeze. But the problem is when I revisit my code 3 months earlier, even if I really spend a lot of time trying to write good code. And the problem escalates when I write that really big application and when I write that big application together with 10 people, or maybe 20 people, or maybe 50 people. And that's pretty much the background for my interest in Elm, and really should is the context for this talk. So let's go back to the slides. So when I say the JavaScript of today, for me that's React and Redux. It's a great package deal for doing large-scale JavaScript development, so I'd like to compare it with that. So Elm is a language compiling to JavaScript. It's not a framework, and it's not a library. So you can't directly compare it to React or Angular or Vue.js or any one of those. And being a language and not a framework, it can go a bit farther in the promises it delivers. I mean, the development experience it can give you and just simply the entire package can be a bit more. It can be more, just like Apple controls the entire ecosystem. They make the hardware, they make the software, they control the distribution through the App Store. They can go a bit farther in what they can offer you. And that's a bit of the thought behind Elm as well. And thus, Elm and JavaScript are totally different. They don't intend to be a tool that you can just add on to your existing tech stack. It's a completely different way of solving the problem. So it's different in terms of semantics, but also, of course, in terms of syntax. But on the other side, Elm uses pure functions and a virtual DOM, similarly to what React started with, and now all of the other JavaScript frameworks are doing. So you create this tree of components, and that's the way you create your front-end app. But Elm does not allow for component state or local state. You have all of your data at the top of your application, just like with Redux. So basically, Elm uses the Redux architecture. But the thing is that it's actually the other way around. The creator of Redux, Dan Abramov, this guy from St. Petersburg in Russia, he actually tried out Elm and really liked the way of developing with Elm and the architecture that you use in Elm. So he thought, let's try this in JavaScript. And out came Redux, which is now maybe the most popular web framework out there. So I would say that Elm is basically React Redux with type safety. I'm a big fan of React and Redux, and my friends come up to me and say, hey, you said I should use React and Redux. Does that not apply anymore? Should I jump ship to Elm? And my thoughts is that React Redux is great, but if you're willing to ditch JavaScript and go even further in search of bigger promises and even better workflow, yes, I think Elm is better. But it's the same way of working. It's just that Elm gives you type safety and a more solid experience. So let's see some code. Just like with React, you would compile your Elm code down to a single JavaScript bundle file, and you would include it in your HTML with a script tag. And then you would simply tell your Elm app to render into a specific DOM node. Like here, we render it into the container node. So it's easy to use Elm on just a part of your application, just like Facebook did with React. They started using React only on the chat part of their app, because it was the most complex one, and also the one with the most real-time data. So it's simple to try out Elm on just a part of your app. And let's have a quick overview. Just like with other similar languages, the biggest focus is on correctness, maintainability, and developer friendliness. Your code should be almost mathematically provable that it will be running without bugs. So it's a functional language from the ML family. So it's similar to F#, OCaml, and Haskell. And I guess just like React had the virtual DOM as the major selling point during the early days, Elm has the no runtime errors argument. So it's possible to have runtime errors in Elm, but you almost have to try to get them. The biggest Elm adopter in the world has about 250,000 lines of code, and they have never had a single runtime error in production, with over 1 billion page views. And it's heavily opinionated, where JavaScript is so flexible, you can bend it any way you want. You can use it in this way, functional way, object-oriented way, whatever. Elm is a really narrow box. Elm provides a single way to solve every problem, and it's very opinionated. This is the way you format your code. This is the way you architect your applications, but they are really thought through. They have an extreme focus on this. So for some people, that buy-in is too hard. They don't like to be controlled in that way. They like the flexibility of JavaScript, but that's just the way Elm works. So these are the key language features. All data is immutable, and there's no null. And the big point with that is that there's no null pointer exception. And that's the big part of the no runtime errors thing. It's all expressions. There's no statements. So unlike F#, where you have both statements and expressions, in Elm there's just expressions. Everything evaluates to a value. The language is pure, so all the side effects are handled by the runtime. So if you need to do a network call or access local storage or whatever, you tell the Elm runtime to do that for you. You don't do it yourself, meaning that all the functions in your code will be pure. Architecture is a built-in feature. There's no question, should we use this way to structure our application? Should we use like Elm Redux or Elm Angular or Elm Vue? It's not a question. You just use the Elm architecture. And that means, for me as a consultant, when I enter a new Elm project, I'm always familiar with the way things are set up, because it's set up in the Elm way. I don't have to learn a new framework. And lastly, it has a very small but expressive feature set. I don't know if any of you saw the talk in this room before me by Scott Blashin on the power of composition. And he talked about composition is like doing Legos. Everything just clicks together. And I think that is really true for Elm as well. It doesn't have that many features, but the features click really well to create bigger systems. But it's therefore pretty easy to learn Elm. I've done a lot of workshops, 4-hour workshops, full-day workshops. And everyone from seasoned developers to grad students in the university, pick it up really fast. You can be productive in a day. So let's see some code. As Elm is a functional language, functions are at the core of the language. So here we have a function increment that accepts one parameter x. And we return that parameter x plus 1. 5 is a constant, which is the result of calling increment with the value 4. So in JavaScript, you would use the parenthesis, but in Elm, you just use the space to call a function. So whenever you see a space like that, it means call function increment with the number 4. There's no types here, because Elm can infer all of the types. It has full type inference. It sees that, okay, increment is a function, accepts something we call x. Aha, x is... you use plus, x plus 1. That means that x has to be a number, because you don't use the plus operator to concatenate strings. Plus is only used for numbers. So Elm can infer that the input value x is a number, and the return type x plus 1 also has to be a number. But as good citizens of Elm, you would also always specify the types. So the arrow means that it's a function. Increment has type int to int. And 5 has type int. The types serve as great documentations for other developers, and they're also a good, they're basically you telling the compiler that this is what I expect from the code that I am about to write. So the compiler can help you out and give you a heads up if you manage to get an error in there somewhere. And with trivial functions like this, the point that isn't that big a point, but when you write real-world applications, it becomes all of the world of difference. So in addition to constants, we have tuples, just using the parents, and also records, which are basically objects in JavaScript. So it gets really interesting when we start talking about types, because types are really critical in functional programming. So we have the type alias notion, like you do in Swift, where you say that coordinates is basically a pair of ints. So whenever we have a pair of ints, you could basically just call it coordinates. So you're kind of creating an alias between those two. You're not creating like a class or a constructor or anything. You're just saying that whenever we have this, something of this shape, we might as well call it coordinates. You don't have to do it for tuples. You can also do it for simple primitives to basically rename a type, which makes it clearer for other people reading your code later. And I guess type aliases are, they work the best when you have records. So let's say you have a customer type, which is a record with field name of type string and a field age of type int. So here's me 6 years ago. So moving on, there's this other great construction in Elm. That's the thing I find myself reaching for whenever I do JavaScript now these days. And it's called union types. And to show you how it works, I have this a bit larger example. So let's say every customer has a type. You're either a student type, you're a corporate customer, or you're a private customer. And let's say in JavaScript you would represent that as a string. So every student customer has a student discount. So let's model that with an int, which is a number between 0 and 100 representing the percentage of discount. So myself, 5 years ago, I would be a student customer and I would have 50% student discount. So that's, in JavaScript, this is pretty much the way you would do it. And then fast forward a few years. So I start working at Beck. I'm now a corporate type customer and I have a student discount of 0, which makes sense because I shouldn't get any discount. But still, it's a bit weird that I have a student discount field there, right? Why is it there when I'm not a student? Now, the developer reading this has to know that whenever the type is student, then that field becomes active. If not, you can just ignore it, but it's still there. So that's a bit weird. Also, it's very easy to mistype the value of the field type. You could write corporate without E on the end, and then your code wouldn't work. It would just blow up in production. Unless you have a lot of tests, of course. So we have this union type construction for this, which is basically like a fancy enum. So you can say that the type customer type has one of 3 possible values. It's either a student, a corporate, or a private value. So far it's just like an enum. What we've achieved here is that the compiler will be able to tell you if you forget to handle a case, or if you mistype it, it will say, I don't recognize the value student of type, customer type. I don't know about that value. But now we've lost our student discount, and we've also lost the company name field. So just like in F#, you can add values to each of the different branches of the union type. So whenever you have a student value, you need to have an int. You can't create a student type without an int. You can see it as that's the student value wrapping or containing an int. And the compiler will enforce this in your code. You simply can't create a student value without passing it an int. It's not possible. Similarly with the corporate value. So the way you unwrap this is through pattern matching. Here we have a function called getDiscount, accepting a customer type and returning a discount, which is an int. So here you see we use the case expression, case class of, and then all of the different possible values of the customer type. So here Elm can actually notify us if we forget one of the branches, and it can detect spelling errors, and it will also type safely unwrap the wrapped values like a discount and the name. So let's say you have a really big application and you, let's say myself as an example, we sell train tickets. And you would think there's just one type of tickets, but that's wrong. There's about 16 or 17. There's a one-way ticket, two-way ticket, only return ticket. There's a period ticket for 7 days, 24 hours, 30 days, 365 days. There's a senior citizen ticket, etc., etc. So that's modeled as a union type at our company. So whenever we add a new type of ticket or remove it, then Elm can immediately run through all of our code and see, you forgot to add that branch in the case expression here and here and here and here. And Elm will simply not allow us to compile the code. So it won't let me deploy that code and possibly have a crash in production. So that's a pretty major sell. Most of these languages have this built-in union type called a maybe or an optional. In Elm it's called maybe, and that you would use that whenever you would use a null in JavaScript. Sometimes you have a value that could be null, or it could point to something. So in Elm you would model this as a maybe. The A here is just a placeholder. It could be an int, could be a boolean, could be a customer type, could be a conference class, could be whatever. So whenever you have a maybe something, you either have just that something or nothing. And you explicitly state that. So whenever you want to unwrap that value and get the just, like the just int, you would also have to specify in your pattern match, what should I do when it's not there? And if you don't do that, Elm will scream at you and refuse to compile your code. And that's the part of the recurring theme for Elm. It will try to help you avoid these mistakes all over your code. And as your code base grows, that becomes a really big thing. So let me show you an example of using a maybe. Let's say we're writing a game. And in the first playthrough of that game, you don't have a high score because you haven't completed the game yet. And after the first game playthrough, you could display the high score up in the corner of the screen or something. So you'd have a maybe int. The first time around it would be nothing, but the other time around it would be maybe int. You would actually have, it would be a just int, because the two branches are just or nothing, right? So let's see how we would unwrap that. We would of course use the pattern match again. So we would do case game.highscore, which is of type maybe int. And then Elm, we would see that, okay, it's a maybe int, so we have either the just or the nothing. And we would have to specify what we would do in both of those cases. And this is similar to how we would do a network call in Elm. You would have to specify what should we do if the network call fails. And similarly for all operations that can fail, like accessing the first element in the list. What if the list is empty? Elm will force you to handle that. So in some way it's a bit more cumbersome because you have to handle all of the cases up front, but on the other side you can sleep without worrying that your code will break because you know that Elm got you covered. So that's it for the types. Let's move on to HTML, which is pretty important in a web application, right? So here's a small snippet of HTML. Let's say we want to create this HTML in Elm and output it to the screen. Like everything else, we use functions. So for every HTML tag, like input, div, span, for, form, etc., there's a corresponding Elm function that you can call in order to create an element like that. And they all have the same function signature. They accept two lists, one list of all of the attributes, like class, ID, etc., etc. And the second list is all of the children. So you see we have a div function, that div has one attribute, which is a class with the value ninja. And the div has one children, which is a span, which again has one children, which is a text node with the string bansai. So it's a bit unusual to read the first time you see this, but you do it in a similar way in React. So if you are familiar with React, it should be pretty familiar as well. And the type of this is this special type defined as HTML. And just like a maybe, you can't just have a maybe. You need to have a maybe something. Maybe int, maybe boolean. Just like with lists, you have a list string, list boolean. You can't just have a list. Similarly, you can't just have HTML. You need to have HTML with something. And that something is what kind of value it will produce back into the system if you interact with the HTML. So let's say you have an on-click listener or a scroll listener or whatever. Elm would need to know what kind of event would that produce. And here we don't have an event, so we don't have any type. We could just put A. But let's say we add an on-click to the span. We would produce a do something cool value and ship that back into the system. And let's say do something cool is of type MSG, just message. That's a convention in Elm. Then the type signature will be HTML MSG. We will see more on this later. So this is the Elm architecture. In its simplest form, it has three parts. You have the model, which is all of the state in your application. If you are familiar with Redux, it's the same thing as a store in Redux. You have all your data in this big blob. Secondly, you have the view, because you need to represent that data in some way in HTML. That's what you output to the screen. So that would be your React tree of components. Lastly, you have the update function. So whenever something happens, like the user times out, the user clicks on the button, the user scrolls, you get an answer from a network call, you would call the update function to see what's the next version of our data. So that accepts the message, which is what happened, the previous state, which is the model, and you have to return the new model. So that's similar to the reducers in Redux. So we've reached the last slide of the first part, and this is how you interop with JavaScript. You use something called ports to send strings back and forth to JavaScript. And if this looks a little bit cumbersome, it's because it is. And it's made that way intentionally, because you need to have a type-safe way to interact with JavaScript. Because your JavaScript code can and will fail at some point, so Elm needs to not to get too close with it. So you could define a save token interface, and in JavaScript say that whenever you pass something on that interface, just call this callback function. Let's say save a token to local storage. And the other way around, you can define an interface that Elm would listen to. And in JavaScript, you would just pass a string to that interface through send. So let's say you're writing an application with not that much logic on your end, but you're just gluing together a lot of third-party libraries. You would have to do this pretty much for every library. So that's a bit cumbersome. So that's one of the drawbacks of Elm again. So let's see which JavaScript libraries you would need to get all of these features out of the box today. You would need React to do the rendering, to have a virtual DOM, create a tree of components. And I guess it's the most popular way of creating web apps these days. You would need Redux to have the organization of your application. You could do it with just React, but that doesn't scale really well. You would need immutable.js or some other library to get immutable data structures. If you want types, and you do in a large application, you would need TypeScript or Flow. And TypeScript is in itself a totally different language than JavaScript. So then you've already taken the step away from only using JavaScript. And also the type safety you get from TypeScript or Flow is great compared to vanilla JavaScript, but it's pretty limiting compared to what you get from Elm or F#. And lastly, you would want to have some way of auto-formatting your code or making sure you don't enter any of the many pitfalls of JavaScript, like writing your entire application using only parents and square brackets. So, I'd like to do a small app for you to show you how it actually works and what the development experience is like. So I'm going to do the example that's maybe the most commonly used in web tutorials, and that's of course the counter app, where you have two buttons, one incrementer and one decrementer, and a number. So let's see some code. Here we go. Let's start with a clean slate. So now you see that we start with the compiler error, because Elm doesn't know what to put on the screen, because every Elm program needs a main function. So let's try to just output hello NDC. We still get an error, fail to compile. Should I get a bigger font for you guys maybe? Can you read this in the back? It's good? So Elm is clearly saying that the main value has an unsupported type. I need HTML, SVG, or a program, but you gave me a string. So Elm can't render a string. And that's a bit of technicality, because in HTML you always wrap text, plain text, in what's called a text node. So we would need to call a function to convert our string to a text node, like this. And then we have something on the screen. So here you see that Elm is very explicit, saying, I expect this, you did this, maybe you want to do this. I think also Elm will, no, it didn't do that in this case, but normally it gives you a suggestion on what function you're looking for, or at least a signature of the function you're looking for. So let's start writing our counter application. So you usually start with the model, like what data do you need in your application? And you would create a type alias for that. So let's say our model in this case is just an int, because all we need to remember is that number, right? In a real application, you would have a large record structure with your user data, some data from the server, etc., etc. So that's the type definition, which is just saying that the model type, that's basically just an int. So let's create a model. So we say model has type model. Notice that the uppercase is referring to an actual type, but the lowercase is just a variable or a constant. So model is, let's just say, start at 0. So you notice that once I save this file, Elm will format it for me using something called Elm format. And Elm format is like prettier in JavaScript. It has a certain way of formatting every possible code snippet, and it ensures that all Elm programs look the same. There's no, should I use semicolons, should I not, should I put this on a new line, should I not? It's just, this is the way we do it in Elm. It looks nice, get used to it, or use something else. So it's a bit on the extreme side. To me, at first, I didn't like the syntax, but then I said to myself, okay, be an adult, spend 2 weeks with it, and see if you don't like it or not. And now it's totally fine. It's just syntax, right? And it's really nice to see that when I enter my colleague's Elm project and they just want a code review or something, I'm immediately familiar with the code because it's formatted in the same way and the architecture is the same, right? So to me, that's a huge win. So let's create a view function to render this on screen. So our view function would take the model and we would return some HTML that never has an event yet. So now you see that Elm is complaining that we have a type annotation, but we don't have the definition. That's right, because we haven't made it yet. So now you see that Elm infers from our type definition what it's supposed to do, so I can just enter like its default implementation. So here we would want a div, and inside a div we would want a button and a span and another button. So I don't care to reformat it. I just save and Elm fixes that for me. So inside of the buttons I would like some text. So I'll use the text function again, like that. And let's render this thing as well. So I'll call the view function with our model, like that. So we need to fill the span with our integer. So we could try to just call a text function with our model. In JavaScript that would have worked because it would just try to like force the types to match and do something with it, like we saw in my example. But Elm is telling me that text accepts a string, but I gave it a model, so I would need to convert that. So the naive implementation here would be to call toString on the model like this. And I should also type it correctly. So it works, but it's a bit hard to read. And you can imagine if I needed to call another function, maybe two more functions, I would start to approach like the parenthesis hell. So here you would use the pipe operator and basically turn the order of the functions around. So I would pipe the model into the toString and the result from that into text. Works much better. And I think actually Elm got the syntax and the idea from F#. So let's start adding some interactivity because the buttons aren't working. So we would start by creating the list of possible interactions in this application, the message type. And this is not a type alias when we say that if something looks like this, you can call it this. Now we're saying that this type has this finite set of values. Whenever you have this type, you need to have either this, or that, right? So our message in this small app is just one of these two possibilities because we don't handle any other events yet. You could add like user timeout or a network call or stuff like that. But in this app, we just have these two. And the nice thing about that is whenever you open an application, you just find the message type, and then you see all of the possible things that can happen in your application. So if your boss comes and asks you, do we support user timeouts? Just check the message type. Does it have a user did timeout message? Then we probably do. If you don't, then you don't handle that scenario. So you don't have to look through all of your code, all of your possibly tens of thousands of JavaScript files to see is it supported. And when we're talking about that, I would also like to point out that this main function is the only thing that could possibly be outputted on the screen, as opposed to JavaScript, where every line in your code could possibly have a selector that goes into the DOM and mutates something and modifies something, right? You never know. You have to scan all of the code or have a tool to do that for you. But in Elm, the output of the main function is the only thing that's put on screen. So it's very clear. It's easier for a developer entering the code base to find out what's going on. So on each of the buttons, we'd say that whenever you on-click these, just fire this event. So that's increment for the top button and decrement for the lower button. So now Elm is complaining because we said that our HTML never has an event, right? But we do, and Elm can see that. So we actually need to update our type definition to make Elm happy. But we are not handling them. We're just, the thing we're outputting to the screen is just the fire and forget, call me once view function. We don't never update it. And this is where the Elm architecture comes in. So we need to actually use something called beginner program, which is like a bootstrap function to kick off the Elm architecture. And that's basically a function that accepts a record with 3 fields. So we need to say, what's our view function? Okay, that's the view function. What's our model? Well, that's the model. And what's the update function? And that's the part we didn't create yet. So we need to do that. So the update function takes a message, like what happened, and what was our state before this thing happened, and what's the new state. So we could just return the old model to see if it compiles, and it does. So we hooked up the types correctly, and Elm accepts our code. So most of the update functions in Elm looks like this. You do a case expression, and you match on what happened, right? Which of the possible values of the message type is it that just occurred? Is it user did timeout, got accounts from server, etc. So here Elm can infer that, okay, this message type, it only has 2 branches. Do you want me to insert them for you? Yes, please. So let's say you have 16 different types of Norwegian train tickets, then that auto insertion becomes pretty handy. So you would say that in the increment case, you would do model +1. In the decrement case, you would do model -1. And there we have a very, very simple Elm application. And you see that all Elm applications consist of these 3 parts. What's our data? How do we represent our data as HTML? And what do we do to our data when things happen? And of course, we have the network calls and all of the other stuff I don't have time to show you in 60 minutes. But all Elm applications are built this way. And they look the same due to the Elm format tool. And yeah, to me, that's a really big win when you're doing large projects with a lot of team members. So let's return to our slides. So we've reached the last part. Does anyone actually use Elm? So my question was this. Elm has been around for quite a few years, attracting attention and generating a lot of conference talks like this one. But is it really ready for production? Is anyone using it in their business-critical, user-facing applications? And if so, what's their stories? And I realized that if I want to actually learn the answers to these questions, I just need to meet a lot of developers, and preferably Elm developers. So the first thing I did was to start the meetup group in Norway to see, is it just me or are people actually interested in this? And it turned out that after about a month with no marketing whatsoever, just the things that meetup.com does for you automatically, we had about 150 members. And mind you, Oslo is quite a bit smaller than London, so that's actually quite big. And we got almost 50 people showing up at the first meetup, which to me was a great success. And now in January 2018, we have about 398 medlemmer, as it's the word is in Norwegian, which is members. And we do one meetup every month. So I just try to talk to a lot of different people there, find out who's actually using Elm, are they using it in production, etc. And we found out that one of the biggest names in Elm was going to Paris for the Elm Europe conference. And we asked him, would you like to stop by in Oslo just on your way home just to do a talk? And he would love to, so we rebooked his flight. And then we had to decide, should we do like a larger meetup, or do we want to do a conference? So of course we wanted to do the conference, and that's where Oslo Elm Day came to be. So it was a one-day single-track conference in June last year. And we had no idea if we would get any people there, but we actually did, so we were very happy about that. We got about 100 people paying attendees, and 10 speakers from 5 countries. Actually, 4 people flew out from the US to talk for us. All of the talks are for free on YouTube if you want to see some more Elm. And we're planning a next edition this May. So, to try to answer my question as simply as I can, does anyone use Elm? In short, yes. People are using Elm, actually, for real stuff. Also in Norway. And it's hard to quantify that, but I would like to show you 2 examples of different teams and companies using Elm and their results. They were also written in Elm for different reasons. So the first one is another conference in Norway called JavaZone, really similar to NDC over there. About 3,000 attendees, like 8 tracks, not just about Java, it's about everything, basically. So this friend of mine was tasked with writing the information screen software. It was a really old JavaScript app. It didn't work half of the time. They wanted something new where they can just push new stuff from the control room of the conference, just the tweets and videos and information, pictures, whatever. And then the app would just load that on the fly. And he was thinking that, okay, I need to write this application in my spare time because it's a non-profit, community-driven conference. And the screens, there are two screens, and they are both 7 by 10 meters, which means that there will be about 140 square meters of my application failing in front of all of my friends, my clients, my friends from school, if I manage to screw something up. So we thought, let's try this Elm thing. I read nice things about it, and I heard that it doesn't fail in production. So he used it, and actually had to learn a lot of stuff on the way because he wasn't that familiar with functional programming. But in short, he really loved it. And the most interesting thing is that also the other people among the organizers liked using Elm. And most of those guys weren't that familiar with the front end. That's why he was tasked with writing this thing in the first place. So they're mostly Java experts, long-time backend developers, really skilled developers, but haven't really found the time or interest in learning JavaScript or modern front end. But with Elm, they felt more at home because they had a compiler, so they had more of a similar development experience to what they were used to from Java, and some of them C#. And also you had the no runtime errors guarantee, and the types, of course, which a lot of people really miss in JavaScript. So now I know they're using Elm for their call for papers, submitting application, and all of the internal applications. And also a lot of more people than just my friend are doing the front-end stuff. And to me, having a technology that can enable all of the team to do both front-end and back-end is immensely important. So let's see, if you have some F# on the back end, then most of your developers will be familiar with this way of working from beforehand as well. So that's one of the examples. And the other one is where I currently work. So I was lobbying to get us to use Elm. It was not just my decision. I had to convince the client and the rest of the team. And I said, let's try to do a summer intern project, because we got summer interns from the university in Trondheim, and they would work for free. For the client at least, and I say, let's rewrite this old thing with where you reserve your seats, and we'll try Elm. If it doesn't work, we could throw it away safely. You won't spend any money on it. And if these two grad students with 3 years of university experience can write this and produce good code, and it works in 6 weeks, then I guess Elm isn't that bad. And in short, the two students really loved it. They would like to spend more of that 6 weeks writing Elm, because they had to spend like 3 weeks integrating it in the mobile code bases, and that was a bit less fun. And the code was good. We did a really thorough code review. And in short, we decided to move forward with Elm. And now we're using Elm for the web site part of things, where we sell tickets. So now we have a team of about 6 developers doing Elm almost full time. So we are really happy with it. And for us, we also felt that some of the backend developers are now doing front-end stuff, and that's really cool. So to summarize, a lot of people are experimenting with or using Elm, and interestingly, 100% said would use again. And to me, that's maybe the strongest feedback that I've learned during this 1.5 years. And the onboarding is relatively easy. If you haven't done much functional programming before, I guess that will be the biggest learning curve. But if you've done some Haskell or F# or Camel or Scala, it shouldn't be that hard. And also, if you've done React and Redux, a lot of the architecture stuff and all of the web-related stuff will feel really familiar. The world's biggest adopter in San Francisco has about 250 lines of code, and they still haven't had a runtime error in production. And that's a really big argument for Elm. Of course, there's some bad use cases from Elm. If you're using some web technology to write a prototype, it's just like a fire and forget application. The argument for Elm isn't that strong. Also, if you're making something that's really small in size, would be easy to maintain anyway in JavaScript. Maybe you're a startup and your development speed trumps quality. You know that you just want to write the code, get it out in production, and test the product market fit, and you don't care if the code looks good, or if you have to rewrite the entire thing a year later. Or if you use a lot of third-party code, because it's a bit more cumbersome to integrate with than just using plain JavaScript. I mean, it works. All of the Elm projects do, but if your app is just integrating the map thing with the geo-positioning thing, then maybe JavaScript is better. And also, if your team is not familiar with functional programming at all, and they're not really interested in learning, perhaps Elm could have a too steep learning curve for you. On the other side, there's some great use cases for Elm. Sometimes you just know that all you know is that the large refactors are coming. You know that you don't know it all. You know that your first take on the domain model won't work. You'd have to iterate and iterate and iterate to get things really well. The complex domain logic is really well modeled in languages like Elm. I mean, Haskell and that family of languages were originally written to make compilers and code that really needs to almost in a mathematically provable way produce the correct output, right? So when code correctness is important, Elm is a great fit. And also, if your team isn't that knowledgeable about JavaScript, as was the case for my team, we had 3-4 people who hated JavaScript, they didn't want to touch JavaScript. So we could either use JavaScript and just leave them for the backend and cloud stuff, or we could use Elm and have a better chance of having the entire team do frontend. So I hope I've been able to share my thoughts on why Elm addresses these pain points. And to summarize, I think that Elm gives you a language without runtime errors. The refactoring support is great, simply because it's statically typed and compiled. You have front-end technology for the entire team. It has a delightful development experience. Just the reduced cognitive load when you don't have to keep everything in your head of how things click together. You just have the compiler. Whenever you do something wrong, the compiler will tell you that you're supposed to return this type here, not this type. Oh, okay, thank you. You have Redux built in, which is perhaps the most popular web solution these days, together with the React that's also built in. And on the bad sides, you have a currently small ecosystem. So if you're really dependent on using a lot of third-party packages, Elm is nowhere near the JavaScript community, of course, because JavaScript is just so abundant these days. You have a language without a huge backer. I mean, React has Facebook, Angular has Google. Elm doesn't have any of those. And of course, since you always need to specify what you would do if the network call fails, or if you try to get the first element of a list and it's empty and it fails, or if maybe it doesn't have a value, you have to write a little bit more boilerplate. So that's the price you pay to get all of the safety guarantees. So I guess the question is it a good deal? I guess it's no secret that I think so. But what's most interesting is what you people think. So I hope that I was able to make you curious during these 55 minutes. I have some recommendations for further reading if you want to learn more. First, a shameless plug. Me and my colleague, we made this free workshop where you implement the memory, the game where you click 2 cards and you try to match the corresponding kittens, called Memory Meow. And that workshop is free, available on GitHub. I will provide the links on the last slide. So check that out if you want to have a step-by-step learning guide on how to write a small application in Elm. Please join the Elm Slack. It's a really friendly community. They have a like policy of trying to answer every single question in the beginner channel. So if you have a question about Elm, just go in there and type it out. And lastly, check out your local Elm meetup. I know there's a large meetup group here in London, and I think they do meetups every other month or so. So please check that out. Please make sure to evaluate the session on your way out using these small post-it notes. And all the slides and the workshop link is available at is.gd/ndcelm. Thanks for listening.